Welcome to the Story in the Brand. This is our Shiva sir. Today topic is electric current. Electric current. So grade 12. JEE NEET. For them it will be helpful. So we'll start electric current. Electric current. Electric current. So electric current is nothing but the flow of charges. The flow of charge is known as electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. I equal to dQ by dt. So it is instantaneous current. Instantaneous current. Instantaneous current. So I equal to Q by T is the average current. Average current. So we can say instantaneous current at the particular instant. At the particular instant, so how much current is flowing? So normally we can say instantaneous velocity, instantaneous acceleration, instantaneous speed, like that. So the velocity at that particular instant, the acceleration at that particular instant, so instant coffee, like that, all these things we'll discuss. Means instantaneous at the particular instant, so what is a current? So that current is called instantaneous current, and average current. So overall actually how much current is flowing in the conductor, that is called average current. Okay, so total current by total time taken, we can say that is average current. Now SI unit current is 1 ampere. Sorry, SI unit current is ampere. SI unit current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. I equal to dq by dt. I equal to q by t. I equal to Q by T. So that is nothing but 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is called electric current. That is called 1 ampere. That is called 1 ampere. I hope it is very clear. Now, here three conditions are there. So three conditions. Condition number 1. So I am taking here delta Q. So charge flow can be obtained by multiplying constant current with change in time or time interval. We can take time interval. So if the current is a function of time, then you can integrate the current with respect to time. So I equal to delta T. And third one, so charge flow can be obtained, or charge flow will be there by area under the IT graph. So this is about electric current. I hope it is very clear. Just check once here. Electric current. So instantaneous current, average current. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So delta Q, charge is flowing. So charge flow can be obtained by multiplying constant current with time interval. And if the current is a function of time, then delta Q equal to Ti Tf I delta T. So charge flow can be obtained by area under the IT graph. So this is about current. And next one, based on the magnitude and direction. So based on magnitude and direction, current can be divided into two parts. So magnitude and direction. Magnitude and direction. Based on magnitude and direction, so current can be divided into two. So one is DC, another one is AC. First one is DC, second one is AC. So DC is nothing but cell, battery, DC dynamo. Okay, coming to alternating current, that is, so both magnitude and direction changes. So that is nothing but AC. AC current, AC dynamo. Here you can observe one thing. So if the charge is moving in the conductor, charge is moving in a circular path, with the frequency, so Q is moving with the frequency F in a circular path. Q is moving in a circular path with the frequency F. Then I equal to Q into F. So that's enough. So based on magnitude and direction, current can be divided into DC and AC. So DC example cell, battery, DC dynamo. AC example AC dynamo. So if the charge is moving in a circular path, with the frequency, so I equal to Q into F. I hope it is very clear to all. Next, so we'll discuss now we will discuss about drift velocity and relaxation time. 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 Relaxation time. So what is your drift velocity? Drift velocity is nothing but, so normally you can observe here, so this is the conductor, so current is flowing in this direction, electric field will be there, so electrons are moving in a particular direction, so this is the drift velocity. So anyway, electrons will move in zigzag motion, so we are taking a drift velocity in a particular direction, means electrons are moving just for, so this diagram shows current is moving in one direction, electric field is moving in one direction. Okay. So once check here. Okay, done. So now you can observe here. So your current is moving like this, electric field is there. So the electrons are moving opposite to that, opposite to this direction. Now you can observe here. So when electrons are moving in the electric field, when electrons are moving in electric field, it experience force. Yes or no? It experience force. Now you can observe. So F equal to Q into E, F equal to E into E. So we know F equal to MA. F equal to MA. So MA equal to E into E, then A equal to E by M. Okay, so I hope it is very clear. So this enough. Acceleration equal to E by M. So drift velocity is nothing but, so one electron will move in this direction, one electron will move in this direction, this electron will move in this direction. So like these electrons will move with a different velocity. Okay, electrons will move with a different velocity in the conductor. Okay. So when electrons are moving in the conductor, so those electrons will move in different direction, zigzag motion. So what happens when it is moving with a different velocity? It will hit with another electron. So on one electron will hit another electron will hit another electron. Like that, keep on bombardment, keep on collision takes place, keep on bombardment takes place, keep on collision takes place. That time what happens? So this is moving. So suppose, so I'm moving with 20 meter per second. So another electron is there beside of us. So if I hit like this, so this electron also will hit another dishka. So this electron will hit another electron. Like that, keep on bombardment takes place, keep on collision takes place. Tin, 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 tin. So keep on collision will takes place, keep on bombardment takes place. Then what happens? So I am moving with a different velocity. So another electron will come. This electron will come. This electron will come. Done. So when I keep on colliding with each other, so what happens? My velocity decreases. After that, another electron velocity also decreases or not? Yes or no? So if I hit this electron, this electron will move with a different velocity. So if I hit with another electron, that electron also will move different velocity. So combined average. So if you observe average velocity of an electron moving in the conductor is called drift velocity. Okay. Okay. So like that, when keep on moving, so electrons will collide each other. So automatically the average velocity of an electron will changes. Yes or no? So changes. So that's why each and every electron will be having different velocity. So when it is moving with the zigzag motion, so it is moving a similar path, so same path. So one electron will hit another electron will hit another electron, like that. Keep on bombardment takes place, keep on collision will takes place. Then what happens? Automatically velocity changes. So the average velocity of an electron moving in a conductor is called drift velocity. So next one. So you can see relaxation time. So relaxation time is nothing but, so I'm standing here. Okay. So electron came. So I hit. Okay. So I'm hitting like this. Another electron came. So hitting. So after each and every collision, so there is a time gap between one collision to another collision. Okay. So electron is there. Here also electron is there. So I'm okay. So I'm colliding. So collision takes place between one collision to another collision. There is a time gap between. Immediately it won't happen, right? So it will take time. So 1, 2, 3, like that it won't happen, right? So after one collision only, next collision will takes place. So after one collision only, next collision takes place, right? It keep on won't takes place. It will take some time. And at the same time, so one collision to another collision gap will be there. And so the same, like so many collisions will take place in the conductor. So many collisions will take place in the conductor. Only one collision won't take place. Different collisions. and different time. So the average time gap between two successive collisions. The average time between the two successive collisions. The average time between two successive collisions is called relaxation time. Is called relaxation time. Understood? So one collision to another collision, another collision to another collision. So it keep on collision takes place. Then what happens? So the gap between the average time between the two collisions. So two successive collisions. That two successive collisions is called relaxation time. Is called relaxation time. Relaxation time. I hope it is very clear. Okay, so this is about relaxation time. Drift to velocity and relaxation time. Drift to velocity and relaxation time. I hope it is very clear. Is it very clear? Yes or no? Yes. That is about drift to velocity and relaxation time. So now we are going to the next one. That is so now you can see so I mentioned grade 12, right? JEE, NEET, electric current. Okay, so it is topic is mentioned like that. Actually that is fixed one, like that it is there. So actually grade 12 it is. Grade 12 JEE, NEET also will come. Grade 12 physics. So JEE and NEET students also can join JEE and NEET. Okay, done. Now we will discuss about one more topic, that is drift velocity, current and drift velocity. Current and drift velocity. Right? Chalo. Then this is the conductor. Current is moving inside of it and electric field is there. So electron is moving, drift velocity I am taking. So this area of the cross section. This is area of the cross section. Okay, so this is also area of the cross section. Area of the cross section. Here also area of the cross section. Understood? Now you can observe velocity equal to displacement by time taken. So here VD is there, VD, and this one is the length of the conductor, that is nothing but displacement, and time delta t. So VD into L by delta t, that is nothing but L into VD delta t. So VD delta t. Okay, so that's enough. Understood? So I hope it is very clear. VD into delta t, that is nothing but length. So now you can find out the volume. Volume equal to length into area. So volume equal to length. Length is how much? Length equal to VD into delta t, right? So change, delta is nothing but change in interval. Like if you are taking, so from here to here, so I started moving. So initially with a certain temperature, after moving, so here certain temperature is there. So the change in temperature is called delta. So change in physical quantity, or anything you can take, either change in velocity, change in acceleration, change in time, change in speed, like that different. So we can consider like this. So that's why it is changing. That's why we are telling delta. So here L into L is nothing but what VD into delta T into A. That is volume. So don't get confused between so V and volume. So I'm mentioning with words. So this is the volume. Volume. So I hope it is clear, right? So in a particular volume, number of electrons are present in a particular volume. So how many electrons are present? That we will discuss, right? Number of electrons present in the particular volume. Volume. Number of electrons present in the volume. Number of electrons. Number of electrons. Number of electrons. Number of electrons present in this volume. Present in this volume. Dun, 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 dun. So for everything there is elevation. So when you are walking, when you are moving, when you are talking, when you are delivering the content, when you are delivering the dialogues, everything there is elevation. So for every subject it must be there. Okay, so this is our elevation. Dun, 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 dun. N PD delta T into A. So now delta Q. I am perfectly okay. I am very good. So here number of electrons. Now you can see delta Q, flow of charge. We know quantization of charge. Quantization of charge. What is the quantization of charge? So quantization of charge. So we'll discuss quantization. What is the quantization of charge? Number of electrons into number of electrons, N into E. Hey, you said you are in fifth class. So how you got that formula? Very good. But still. Okay. So delta Q equal to N means N into VD delta T into A into E. Okay. Now we know current. So what is current? Current I equal to delta Q by delta T. So current I equal to delta Q by delta T. So now you can see what is the delta Q? N into VD into delta T into A into E by delta T. So delta T delta get cancelled. Then the answer is N VD A into E. Okay. So now current density. Oh, great. Good job. So current density J equal to I by A. Current density J equal to I by A. So N VD A into E by A. So A get cancelled. Then N E V D. So this is the current density formula. Current density formula. Okay. So current density J equal to NEVD. Okay. So this is the answer. So check once. So this is the formula. I hope it is very clear to you all. So once again, V equal to L by T, L equal to VD into delta T, volume equal to L into A, volume equal to VD into delta T, number of electrons present in the particular volume. Current is a scalar. Scalar quantity does not follow vector law of addition. And here you can observe, so I am taking I equal to delta Q by delta T. So delta get cancelled. Then current density will get. Okay, so current density is equal to current density I by A. I by A. I hope it is very clear. Now we'll discuss about one more. Resistance and resistivity. Resistance and resistivity. Yeah. AC, DC, current is divided into two parts. based on magnitude and direction. Current is divided into two parts, AC and DC, based on magnitude and direction. So resistance and resistivity. Resistance and resistivity. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing. Resistance is the device. Resistance is not a device. Resistor is a device. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is the device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay, so R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Okay, so now you can observe here. So rho is the resistivity, R is the resistance. So resistance and resistivity. So resistance and resistivity. Resistance is the phenomena of opposing the electric current. Resistivity. Okay. So now you can observe here. Okay. So resistance and resistivity differences we'll discuss. Resistance and resistivity. Resistance and resistivity. Resistivity. Okay. So one R equal to rho into L by A. So first one rho equal to RA by L, and the second one SI unit of resistance is ohm. Here SI unit of resistivity is ohm meter, and the third one resistance is the resistance SI unit is, and depends on temperature. So third one here resistivity depends on temperature, and coming to the resistance depends on material of the conductor. So resistance is depends on material of the conductor. Material. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So resistance depends on length of the conductor and area of the cross section also. So these points are very important. Just check once. So R is directly proportional to L. R is inversely proportional here. R equal directly proportional to L by A. R equal to rho into L by A. Okay, so resistivity, resistance. So R equal to rho into L by A. So rho equal to RA by L. So SI unit of resistance is ohm. SI unit of resistivity is ohm meter. So resistance depends on temperature. Resistivity depends on temperature. Yes, nature of the conductor. Yes, correct only. So resistance depends on nature of the material. Resistivity also depends on nature of the material. Okay, done. So I hope it is very clear. So this is the point. And here resistance also depends on length of the conductor. Resistance also depends on area of the cross section. Okay. Yeah, that is true. Correct. Okay. So next one. So now we'll discuss about temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. Resistance. Na na ni na 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 ni na na ni na ni na 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 ni na. Yom and I will discuss after some time because now we are going with the electric current topic. Yom and magnetic effects of electric current I will discuss. Slowly one by one I will discuss. Okay, done. Come to the point. So actually when temperature increases, two things will happen. Temperature increases, two things will happen. Temperature increases, two things will happen. First, point number one. Okay, so when temperature increases, free electrons increases. So electrons will move with a greater amplitude. So that conductivity increases. Actually, when temperature increases, two things will happen at a time. So I'm explaining one by one. One by one I'm explaining. So point number one, when temperature increases, electrons, number of free electrons increases. So electrons will move with a greater amplitude. So with a very fast, with a greater amplitude, it will move so that, so conductivity increases, by that resistance and resistivity decreases. Point number one. Point number two, same thing. So if movement of the electrons increases, so velocity of the electrons increases. If the electrons are moving in the conductor with a greater amplitude, what happens? So those electrons will hit another electron. So as just now I explained, drift velocity, one electron will hit another electron, one electron will hit another electron. So then keep on bombardment, keep on collision will take place. So with a more frequently collision will take place. More frequently collision takes place. Then what happens? Electrons will not move forward. So their own collision will take place. Hitting, collision, fighting. So every time fighting will happen, so in the conductor. So one electron, another electron, another electron, dun. Tada. So keep on moving collision. So keep on fighting. So keep on collision takes place. And what happens? So they won't move forward. They forgot to move forward. Okay, so what happens? Collisions will take place. So keep on collision takes place, they won't move forward. Then what happens? Then conductivity decreases or increases? Decreases. Resistance increases. Resistivity increases. Temperature increases. Resistivity increases. Resistance increases. Temperature increases. Resistance increases. Resistivity also increases. Okay, na? So two things will happen at a time. Once again, so I'm repeating once. So when temperature increases, so free electrons increases in the conductor. Then what happens? So automatically the electrons will move with a greater amplitude. Here. So with a greater amplitude it will move. Then what happens? Conductivity increases initially. Conductivity increases, by that resistance and resistivity decreases. One point. Coming to point number two, what happens? So immediately when electrons are moving with a greater amplitude, so collisions will take place. Collision will take place. What happens? Collision will take place. Bombardment will take place. Hitting will take place. So then what happens? There only collision will take place. Fighting will take place. Moving it will take place. Then what happens? They want to move forward. By that, so that conductivity decreases. So we are keep on thinking, what is this one, what is that one? Well, we get the rank, when we can prepare this concept, we can write the exam, we'll get the score. So you are keep on thinking. You keep on thinking, right? When you keep on thinking, so when you prepare, when you practice, when you write the test, when you write the test, okay, so how you'll get the rank, how you'll get the marks. So remove all those negativities or negative thoughts. So keep focus on work, keep focus on work, do no problem, continuously, constantly do your work. Only work is do your work. That's enough. Nothing happens. Whatever the comments, negative comments, say negative comments will start in your mind itself. Yourself, your thoughts only your opposite persons. Okay, our enemies. So negative thoughts only your enemies. Overcome those negative thoughts. Negative thoughts. Overcome those negative thoughts first of all. Okay. So someone see, you say I'm wearing this dress. So I'm wearing this. I'm teaching the concept only. I'm not doing anything. I'm teaching the concept. I'm delivering the content in a best possible way. So in my own way, right? So I wore in this dress, somewhat different. I can agree. So people how they'll, so what is this dress? What is that one? What is this concept? What is that one? So if you keep on thinking, if keep on think like that, if I stop doing all these things, so who will suffer? Yes or no? So finally, the delivering the content, it may lose. Yes or no? The process of delivering the content, it will stop. So that zero results. So instead of that, so I'm doing myself instead of thinking like that. So thinking is a positive. Thinking is in that way. I'm doing my work. I'm delivering the content. I'm delivering to the students. I'm whatever I know. I'm explaining to the students in a best possible way. So those who really need, those who are really preparing, those who are real aspirants, those who want to know the subject, they'll concentrate on the subject. They will learn the subject. So I'm explaining a different way. So if you like the content, if you like the explanation, they will come and watch. So in that way, I will think. If I think in that way, definitely I'll continue. So same thing I'm telling to everyone. So remove your negative thoughts. Remove your negative thoughts. Nothing will happen. Okay now. So everything will be here itself. Here itself. The problem is here. Okay. So when I'm preparing, so if you keep on 24 hours, someone will think, hey, why he is doing 24 hours, he is preparing, but he is not getting results. So like that. So if you are playing 24 hours, so someone will have thought, why he is not preparing, he is not studying, he will not get rank, he will not get good mark, he don't get good life. Then, yeah, that's enough. So if you are good, if you are doing good, also have comments. If you are not doing good, also have comments. So if you are doing mid, okay, somewhat you are preparing and somewhat you are time. So you are utilizing your time to do your work. Still they have comments. So only he is getting half marks. How can he get rank? So only getting 50%, 60%. How can he pass the exam? How can he get rank in the exam? How can he qualify in the exam? So everyone have their own thoughts, right? Your own negative thoughts. First to remove your own negative thoughts. After that you can face remaining negative points, negative comments. First remove your negativity. Everything is here. Remove that. Remove that cover of negative thoughts. That's enough. Take like this cap, you can take it and keep outside. Then you wear good thoughts. Okay, na? Good thinking. And focus on your work. Do your work. Do your work. Chalta. It goes. That's enough. Nothing else. It goes. It happens. Do your work. That's enough. Nothing else. Everything will go. Everything fall into the path. Do your work. Always do your work. Okay, whether it is negative, chalta go. Whether it is positive, chalta go. Whether it is hard time, it's okay fine. Whether it is good time, it's okay fine. Whether it is in between, it's okay fine. It is not supporting. Your health is not supporting. So time is not supporting. So your parents are not supporting. Your friends are not supporting. Your teachers are not supporting. You are there for you, right? You are there for you, right? You do your work. You are there for you. Only you. You can understand yourself. The one who can understand entire the world, only you. Hold your hand. Hold your thoughts. Move along your thoughts. Go along your thought. Definitely. Definitely you will do your work. Okay? So, yeah, of course, whatever it happens, be confident, stay positive, always move towards your goal. If your goal is really good, if your goal is really achievable, definitely you can achieve. Only twice things will born. Okay? So it takes birth. Only twice. One is in mind, one is in reality. If it is, if the thought is takes birth here, definitely it will take birth on reality. Okay? Definitely you'll get it. Definitely you'll get it. So those who, so to whom it is helpful, to whom it is useful, to whom it is acceptable, please take it. Thank you. So thank you so much for that. Definitely I will deliver my content in a best possible way. Okay, done. So now if the temperature increases, what happens? So a number of electrons increases. Number of electrons increases. Yes or no? Number of electrons increases. So that electrons will move with a greater amplitude, so that conductivity increases. Initially conductivity increases, by that resistance and resistivity decreases. Immediately the second point, when the electrons are moving with a greater amplitude, so those electrons will hit the another electron. Those electrons will hit the another electron. Then what happens? Collision will take place, bombardment will take place, then resistance increases, resistivity also increases, right? Yes. Now we can go through it. Now you can see R is at temperature T, R naught is at temperature T naught, rho is at temperature T, rho naught is at temperature T naught. Okay, now you can observe R equal to R naught plus 1 plus alpha into T minus T naught. So alpha is the coefficient of temperature, coefficient of resistance. So alpha is the temperature coefficient of resistance. Okay, done. So R minus R naught. So plus R naught into alpha T minus T naught. Then R minus R naught equal to R naught into alpha T minus T naught. Then alpha equal to R minus R naught by R naught into T minus T naught. Then R minus R naught by R naught into delta T. So that is alpha equal to R minus R naught by R naught into delta T. R naught into delta T. Okay, so this is the answer. H equal to I square RT. So that is also known as Joule's law of heating. So heating effect of electric current. Okay, so alpha equal to rho into rho naught by rho naught into delta T. Singh DC Pandey and HC Verma. Okay, so that's enough. So this is about alpha is the temperature, coefficient of resistance, and here also resistivity we are taking. So this is about temperature coefficient and temperature dependence of resistance. The next one we'll discuss about Ohm's law. Now Ohm's law, Ohm's law, Ohm's law, Ohm's law, Ohm's law, Ohm's law. Dun, 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 dun. Ohm's law now. Yeah, definitely we can do it. Problems wise, yeah, so you can follow that book. It's really good. So content wise and problems wise, you can definitely. But so fix to one book first, learn the content, then you can compare. So any extra point. So wherever you prepare content, okay, content is very important, right? Content you have to learn first. After that, you can go with the extension. Yes, correct only. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature, and physical conditions also same. So the potential difference across the ends of the given metallic conductor. Yeah, correct. Yeah, many books are there. Many books. If you go with like that. So try to do PYQs. Learn the concept. So the point is learn the concept. So whichever book you are following, learn the concept. Do PYQs. Many number of PYQs. More number of PYQs. Okay. Try to do PYQs. Models at the same time. So that all I am telling. So whatever book you are following, learn the concept first. Do PYQs because models are very important. Sometimes same model questions also may come, and like so model questions. So try to learn the questions first, how it is, how they are giving, how to solve it, and what is the formula. Then you can revise more number of times concept as well as okay how to apply those formulas in the problems. Everything will get it. Yeah, and one more thing. So students, I am already started one thing that is free demo classes. Free demo classes like that. All the subjects for 10th and 11th and 12th demo classes are going on. Okay. Demo classes are going on. Demo classes, you can attend the demo class, join to the demo class. If you like the content, so you can directly take classes from the teacher, okay, particular teacher which you are joined in the demo classes. So we started the movement of demo classes. Every day demo classes will go on 9 p.m. at exactly 9 p.m. 9 o'clock demo classes will go on. So you can join to the demo classes. So not only particular subject, remaining subject. So grade 11, grade 12, and not only grade 11, grade 12, and 6th, 7th, 8th, 9th, 10th, so 11th and 12th. Okay, so like remaining subjects also, you can get the classes. So experienced faculty members are available, experienced people are available. So they will take the classes for you. So depends. So after discussing with them, you can get to know. So initially we started with the demo classes. Directly teacher will contact you. Directly teacher will speak with you. Directly teacher will take the classes for you. So you can join the demo classes at 9 p.m. Every day at 9 p.m. in Zoom class. Okay. Okay, so join to the classes, attend the classes, listen the classes, if you like the content, if you like the explanation of them, you can take the classes directly from particular teacher who is taking demo class. Okay, so not only demo class, if you want a remaining class also, you can let me know. So this is the number 9849812804. This is the number. So, and one more thing, you can see the Instagram page. So link is given in the description. You can check once. And WhatsApp channel also there. Join to the WhatsApp channel. Okay, so in that also we'll update the demo classes, and more experienced faculty members are there. All the subject, not only one subject, all subject faculty members are available. So if you want, you can join to the classes. You can take the classes directly. You can talk with them. So, and one more thing, one-to-one call, doubt clarification. So our video call is available, and so a particular doubt, and mentorship also. Mentorship is available. So if you want guidance from particular teacher and particular subject, okay, so you can get from them. So mentorship is available. One-to-one guidance will be available. One-to-one call. Over call also they will clarify your doubts. And over Zoom class, you can get the classes. Okay, so this is about okay, demo classes. Every day 9 p.m. So classes will be there. You can join to the classes, attend to the classes. If you are interested really, if you want to know the subject, definitely this platform. Okay, this is the platform. Directly we are giving the classes. So demo classes every day, not only whenever we want also. So we'll provide. So daily at 9 p.m. Demo classes will go on. Daily at 9 p.m. demo classes will go on. So try to join to the demo classes, attend to the demo classes. Definitely you'll get it. So one fixed time I'm giving. Okay, demo class at particular 9 o'clock. So attend the classes, whatever it may be. So try to attend. So you can get to know the subject. You can get to know the, okay. So you can get to know the, what you know, what you'll get to know. So how they are explaining, how they are delivering the content. So everything will get to know. Okay. Done. So come to the point now. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. So if you draw the graph, for VI, so I'm taking like this. So V on y-axis, I on x-axis. So the graph is like this. So like that you can observe. The graph is straight line for ohmic conductors. Okay, so now, so the graph is linear, so it is for ohmic conductors, the conductors which obey Ohm's law. And coming to non-ohmic conductors, so I'm taking like this. This is for non-ohmic conductors. So the graph is not a straight line; it will be curved. So so non-ohmic conductors, non-ohmic conductors. This is for ohmic conductors. Non-ohmic conductors and ohmic conductors. So ohmic conductor, the graph is straight line. Non-ohmic conductor, the graph is curved. Okay. So that's enough. So that's why you can only send a message. Only message. No calls, because of many number of calls it's coming. I can't able to reach out you all through calls. So at a time. So try to send a message if you want classes, if you want a subject from experienced faculty members. I am telling clearly, experienced faculty members, already they are working. Okay, so already they are working. Like if you want extra classes, you can get from them. So in the evening time. Yes, as I said, so different people are there. So attending. Chalo then. Resistance. Now electromotive force. Electromotive force. Electromotive force. Electromotive force. Electromotive force. EMF. EMF. Electromotive force. So here when you connect the cell to the resistor or in the circuit, current started flowing. Yes or no? Current started flowing. So positive charges will move from positive terminal to negative terminal. Positive charges will move from positive terminal to negative terminal. Whereas electrons will move from negative terminal to positive terminal. Yes or no? Positive charges will move from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. That's enough. That's already we know that. When you connect a cell, it happens. But how the charges, positive charges will move from negative terminal to positive terminal inside of the cell. So how the charges will move from negative terminal to positive terminal in the cell? How it is? The influence make the positive charges to move from negative terminal to positive terminal in the cell, inside of the cell. So the influence, the force, the influence is makes the positive charge to move from negative terminal to positive terminal in the inside of the cell. Inside of some force is required to bring unit positive charge from negative terminal to positive terminal of the cell. Okay, now so inside of the cell. Okay, so that's enough. That is the force which is influencing, which is applying to bring, or the work done to bring unit positive charge from negative terminal to positive terminal. So inside of the cell is called EMF, electromotive force. So E equal to W by Q. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the cell is called EMF. EMF. That is nothing but electromotive force equal to W by Q. W by Q. I hope it is very clear. Right. So that is about EMF. Next one. Internal resistance. So here cell is there automatically when the electron, so charge is moving or electron is moving inside of this cell, then it experiences resistance, that is internal resistance denoted with a small r. So EMF is greater than, that's why it is moving. So E minus R, that is the potential. So V equal to E minus B, E minus R. Potential EMF, right? Okay, done. Now we can take resistors are connected in series, resistors are connected in parallel. So resistors are connected in parallel combination. Resistors are connected in series. First we'll take series, next we'll take parallel combination. Resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. Yes or no? Now you can check here. So 3 resistors, 1, 2, 3. So 3 resistors, ammeter, and here I am taking battery, switch. So R1, R2 and R3. So here V1, V2, V3. V1, V2, V3. So current is passing. So So positive charge, negative charge. Okay, done. Now yes, ma. If resistors are connected in series combination, now you can take. So current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Current is same. So V equal to IR. V equal to IR. So now Vs equal to V1 plus V2 plus V3. So that IRs equal to IR1 plus IR2 plus IR3. So I am taking I common R1 plus R2 plus R3. So I get cancelled. So RS equal to R1 plus R2 plus R3. So resistors are connected in series combination. If n number of resistors are connected in series combination, RS equal to NR. So this same formula will be using in cells, grouping of cells. So next one, resistors are connected in parallel combination. So same formula, okay. So like, so in the form of cells we'll use. Just check once. Now parallel combination. So ammeter. So now you can observe resistors are connected in parallel combination. So V equal to IR, I equal to V by R, V by R, V by R. So V I am taking common. V I am taking common, okay? So V I am taking common. So we am taking common. We am taking common. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Understood? So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if n number of resistors are connected in parallel combination, then so you can check once now. Now Kirchhoff's laws. We'll discuss Kirchhoff's laws. So the algebraic sum of current reaching to a junction in a closed circuit is equal to 0. Algebraic sum of all the currents reaching to a junction in a junction. The algebraic sum of all the currents in a junction in a closed circuit is 0. Means actually Kirchhoff's laws so now you can observe, so junction, Kirchhoff's laws, Kirchhoff's laws. So one is junction, another one is loop. Junction, second one is loop. Junction is nothing but it is a point in a conductor. It is a point in a junction where all where all two or more conductors will meet. Junction is a point in a circuit where two or more conductors will meet. Okay, that is called junction. So if you are taking current like this, so I1, I2 and I3 and I4. So junction lies algebraic sum of currents at a junction in a closed circuit is equal to 0. So I1 plus I2 equal to I3 plus I4. So current reaching to the junction is equal to current leaving from the junction. Current reaching to the junction is equal to current leaving from the junction. So second one, loop. So it is very important, loop. So in loop there are 4 points are there. So listen carefully. When you are passing through the source, so here I am taking, so cell, like cell. So here positive terminal, negative terminal. So this is the path, you are moving along the path. So this is the current you can take. Okay, so when you are moving from negative terminal to positive terminal, so final destination, so when you are moving from negative to positive, so the EMF is positive, because so finally to which point you are moving, so positive, so negative positive we have to take, we are moving from negative to positive, so the EMF is positive. Now when you are moving from positive to negative through the source, so current is passing like this. So here negative positive, so when you are moving, so here negative to positive, so we can take like this, and here EMF is negative because you are moving from negative to positive. Sorry, here negative to positive to negative, here negative to positive. Positive means finally what is the final point, final destination. So their final destination is positive, right? So here negative to positive you are moving. So final destination is positive. So positive EMF. So here negative, positive to negative. Final destination is negative. So negative EMF. So negative. So like that you can remember. And once again listen carefully. So when you are moving through the source, negative terminal to positive terminal, the EMF is positive. When you are moving from positive to negative, so the EMF is negative. Now, so you are moving through the resistor. So along the current direction, when you are moving along the current direction, the potential, that is nothing but I atom, is negative. So when you are moving opposite to the current direction, so current is moving like this, so atom is here, you are moving opposite to the current direction, the atom is positive. So here decreasing the potential, here increasing the potential. That's why we are taking. So these 4 points are very important. So in the loop, especially in the loop, these 4 points you have to remember. Understood? Once again listen carefully. When you are moving through the source, through the cell, so negative to positive. So final point is positive. So that's why, so you have to consider positive EMF. When you are moving from positive to negative, so you are reaching to the negative terminal. So negative EMF. So when you are moving along the current direction, so through the resistor, so the I atom is negative. So along the current direction, if you go, then I atom potential is negative. So because decreasing potential, here you are moving opposite to the current direction, and you are moving opposite to the current direction, so the IR term is positive. IR term is positive. So this is very, very important when grouping of cells. So grouping of cells will use Kirchhoff's loop law. So in grouping of cells, we'll use Kirchhoff's loop law. So make sure that you are understanding, you are following, you are practicing these points. Understood? So I hope it is very clear. Next. Now one more. So V equal to W by Q. So W equal to V into Q. So P equal to W by T. So rate of doing work. So then VQ by T. That is V into Q by T is. So I equal to Q by T is current. Then so P equal to VI. So energy equal to P into T. P into T. Okay. P into T. So VI into T. So E equal to, so IR into I into T. So H equal to I square RT. So energy is given to the conductor, that will become in the form of heat. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is the energy dissipated in the conductor. Okay, energy dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current or Joule's law of heating. Heating effect of electric current or Joule's law of heating. So V equal to W by Q. So we know potential W by Q. W equal to VQ. P equal to W by 2. So the VQ by T. So W equal to VQ, right? VQ by T. So Q by T, that is nothing but current. V into I. So P equal to P into T. So P equal to VI into T. Equal to IR into IT. So H equal to I square RT. Okay. So that's enough. This is also known as Joule's law of heating. Now, grouping of cells. Grouping of cells. Actually, grouping of cells, it will take nearly one more 40 minutes. 40 minutes it will take, because so we need to explain very clearly. So in depth. So it won't happens within 20 minutes, 10 minutes. It will take nearly half an hour to 40 minutes. So we'll take one more class, grouping of cells. So thank you so much for joining and attending and listening my class. If you like the video, if you like the content, if you like the explanation, do like, share and subscribe to Student Indie Brand. So if you like the content, so you can inform to your friends, ask your friends to join to the class. So thank you so much, and at the same time you can attend the demo classes. Demo classes are going on daily at 9 p.m. Okay, so every day at 9 p.m. you will be having daily demo classes at 9 p.m. So try to attend those classes, listen to those classes. If you like the content, if you like the explanation, okay, check once. Thank you so much. We'll see you in the next class.